Hi everyone, welcome to Such Online Academy. This is Ezekiel. Guys, today we are going to continue with our series of Java question and answers. Okay, and in our previous videos, I was talking about this question that I get from the student, from a certain student. He asked me to do a video for him so that he can revise for his exams. Okay, so in our previous video I've already done this first part. Okay, and I'm trying to make this one so much short and quicker so that my video is not going to be so long. So guys, if you are new to this channel, just click the subscribe button. Okay, also to those who have already subscribed to this channel, I have to say thank you for that, because we have already reached our milestone, our target milestone of 30 subscribers, and then our next milestone is 40 subscribers, guys. So all new visitors, can you please subscribe to this channel? So guys, let's dive into our question. Okay, I've already explained about this. Okay, let me just give a quick recap, but you have to go back to the previous video for you to have an understanding of this question. The question says, write a complete Java program with a method front to back that should be added to the linked list class. The method moves the first element of the list to the back end of the list. Suppose a linked list variable named list stores the following elements from front to back. Okay, guys, this was the elements that were needed to pass to our linked list object or linked list variable, and after that you were supposed to take the element at the front, then you put it at the back, like here taking 18 and put that number, the 18 there at the back. That's what we have done in the previous video, so go and check on that video. In this video, guys, we are going to do this one for min to front, where we are going to take the minimum element here and then place it at the front, okay, of our linked list. So here it is if the list is empty, no, another method min to front is to be added to the linked list class. Your method should move the smallest element value to the front of the linked list. Okay, we need the smallest element value. Suppose a linked list variable named list stores these elements. Okay, 7, 9, 12, 5, 3 and 17. Okay, and then if you made the core of list dot min to front, okay, the list you would then store the elements 3, 7, 9, 12, 5, 17. Like you are going to take this 3, the smallest value, this 3, the smallest value, and then we place it here. Okay, we take this 3, the smallest value, and then we place it here at the front of our list. That's what you are going to do, guys. In this tutorial, we're going to take the minimum value, the smallest value element, and then you place it at the front of our list, and we will be using the linked list. Okay, so let's dive into our program. I'm not going to create a new program, guys. I'm just going to use the class that we have, or that we already having. So this is the code for the previous video. That's why I've commented it, place it inside our comments. Then here I'm going to create the new method, which is min to front. Okay, so I'm going to say public, it is not going to be a static method, public, but it is going to be void min to front. Okay, just like this, min to front. And inside this I'm going to create a new linked list, and I'm going to restrict it to take only integers. Okay, to take only integers, and I'm going to give it name list must be initialized to new linked list. Okay, no, here let me just say integer and then here I'll put our constructor. Okay, this is you. Okay, and then here guys, I'm going to add our elements in our linked list using the add method. This method is the one that we were using in our previous video to add the elements in the list. It is the element, it appends the elements at the end of our linked list. So let's do this list dot. We're going to use the add method, and I'm going to add the first element, which is 7. We've got 7 9 12 7 9 12, and we've got 7 9 12 5 3 17 5 3 17. And here guys, this is our linked list. If I print this list, you will see guys, oh no, I have to invoke this method here, just like list dot, using this object guys. I'm going to use this object. Okay, list dot no, I have to say, what I was doing, no, I have to say okay, list dot, I have to say it's min true front. Okay, then let me run this method. This, okay, you see here guys, this is the linked list that we have guys, that we have printed this one. So we have added these elements in our linked list. If you don't know how to add the elements into the linked list, this is how do you add the elements into the linked list. And then guys, let's move on onto the next stage. Here, that's we have to pick this 3, both 3 is the smallest element value in our linked list. So you have to take it and then place it on the front. And here guys, there are also some points that we have here guys, like if the list has more than one occurrence of the minimum value, the first occurrence is the only one that should be moved. For example, 7 9 3 12 5 3 17 3 becomes 3 7 9 12 5 3 17 3. If the list is empty, calling your method should have no effect. Okay guys, what is this saying? These are some key points that you have to note guys. Like, yes, we have to move 3 from here up to here, but what if we have got multiple values of 3? So here, like here we've got 3 3 3 here, and we know that we have to move 3. So but it is saying you only have to move the first 3 here, this one, and then is the one that you have to move here. Like this is what they have done here, and then these 3 will just remain there, and they will just remain there. So we are going to also to do that in this video. Okay, and also if the method is empty, we don't have to do anything. Okay, so here guys, what I'm going to do, I'm going to create another linked list, where I'm going to push all the values from this linked list, and I'll sort them, and then I'll tell you what are we going to do in the next. So I'm going to create another linked list for integers, just to save time. Let me just copy this and paste it over here, and here let me say it's my temporal list. Okay, and what I'm going to do in this temporal list, I'm going to say temporal list dot, I'm going to add all elements of our list. I'm going to add this linked list, guys, this linked list, all these elements. Okay, I'm going to push them into the temporal linked list. That's how you can also use add all method. Can you also use the add all method to add all the elements from this linked list into this temporal linked list? Okay, but this list will also remain with its element. We are not going to move off them, but we are going to copy them into this. Okay, and after that, here guys, you can see if I, and then here I'm going to use another method. This method is under collections, but also the linked list can inherit those methods from the collections class. So we can use the sort method from the collection class. What does this do? Here I'm going to put now. This method is going to sort our elements in the ascending order, so that these three will be at the front of our list. So I'm going to put this at the front of our temporal list, and then I'll take that from the temporal list, and then I'll go to place it in the list at its right position, which is at the front, and then I have to delete it here. This is how am I going to do it. So here I'm going to say I'm going to declare another integer. Let me say our temporal variable must be initialized to temporal list dot should I have to say get unknown? No, let me use even pick method or pull method. I can say pick first, or just to use the pick method, just pick it to take the first element, and then we insert it into our temporal variable. And after that, guys, we have the three that we need, that we want to move. Okay, let me just print our temporal list so that you can see what we have, guys. After sorting this is what we have, guys. You see here, guys, we have this first, the list elements, which is this one, which is this method. This print line is the one which is printing this, which is the list, this linked list. And then the temporal linked list is the one that we have here, and this is this one. And you see here, guys, we've got our 3 at its first position, and this is the value that we have picked from the from the temporal linked list, and this is the value that we have in the temporal variable, okay, which is this 3. So you have to take this 3 and place it here, and after that we also have to delete the value here. So how are we going to do that? I'm just going to say list dot add. I'm going to add. You can even say here add first. You have to say add first. Why add first? Because if you say add, it will append at the end of our linked list. So you have to add this temp at the first position, or at index 0. So I'm going to say, either you can say add let me say dot add first, okay, and then here I'm going to pass temp variable, so that this 3 is the one that we are going to add. And then after that, guys, so now we have the linked list with the 3 here at the front, okay, but also now we have to remove this 3. So how are we going to do that? Here I'm going to use a for loop, guys, just to loop through this linked list, and then I'll pick this value of 3, and then I'll delete it out. Okay, so how am I going to use my for loop? I'm going to do this. I'm going to say for, let me say, int I equal to 0, initialize to 0, then I must be less than here, guys, it's the list dot size, the size of the list, so that we can loop. If we have 5 elements, we have to loop 5 times, okay. Here it's size, then I plus plus, okay, the increment of I. And then what am I going to do here, guys? I'm going to say if I'm going to say if the this list dot get let me just say if my temp variable like my 3 is equal to list dot get, you can use the get method, guys, like get at index I, the value at index I. Like here, if you are at index 0, here it will be, when I is equal to 0, here we will be having the index 0, which means we will be comparing 3 with the we will be comparing not 3, we will be comparing 3 and the value 3 here, and also if then you will be comparing 3 here and this 9, comparing 3 and 12, 3 and 5, 3 and 3, 3 and 17. That's what we will be doing. Okay, so what are we going to do, guys? I'm going to say if we have the value, when we encounter the value 3 equal to that value, then I'm going to remove, okay, I'm going to remove that element. So I think here I've made a mistake, guys, where I think when I say add first, this one I don't have to put it here. Why, guys? Because I will be replacing that, I will be removing that value here inside, so I have to just add it inside my, yeah, sorry for that, guys. So here I have to come here and say if 3 here is equal to is equal to 3 here, that's when I want this to execute, so that I can remove 3 here and I can add that 3 here. Okay, so what am I going to do? I'm going to say, firstly, I'm going to remove 3 here. So I'm going to say in our original linked list, I'm going to say list dot remove, and I'm going to remove what? I'm going to remove the value at index I. Okay, which means if our 3 is at index, maybe, so let's count 0 1 2 3 4. Okay, so our index, if our index is 4 here, which means if our 3 is equal to the element at index 4, yes, we are going to remove that element at index 4. That's how we're going to remove this 3. Okay, and then at the same time I have to add first, I'm going to add that 3 at what? I'm going to add that 3 at the front here, at the front. Okay, and after that let me, this is my, here, this is the for closing the class, so this is my, okay, so here let me just print my list. Okay, let me just print the list and let's see what are we going to get. You see here, guys, we have this result. You see, let me remove this temporal list, I don't think we need it anymore. Okay, and let me run this. You see, guys, let's compare this output. This is our original linked list, and this is our list. We have managed to pick this and then place it at the front and then remove it here. We have removed this 3 here and move it to the front. That's what we have done, guys. We have removed our 3 at index 4 0 1 2 3 0 1 2 3 4. We have removed our 3 at index 4 and place it at index 0 using the add first, okay, method. You see what we have managed to do, guys. This is the thing that we are supposed to do here, guys. We have to move the 3 here up to here, and then here the next point, guys, that we have to make sure that we have cater for is this one, which says if the list has more than one occurrence of the minimum value, the first occurrence is the only one that should be moved For example, 793 12 53 17 3, so becomes 379 blah blah blah, which means guys we have only to take the first element and then we place it at the front, and then the remaining threes we have to be just on their position, on their original position, like this. Okay, so how are we going to do this, guys? Let's come here. Let's first add other elements. Here we have to add another 3, the 3 here between 9 and 12, 3 between 9 and 12, okay, and the other 3 here at the end. Okay, let me confirm. Yes, that's it, guys. So how am I going to do this, guys? I'm just going to come here. Let me just create another integer variable. Let me give it count initialized to 0. Okay, and then here, guys, I'm going to come just inside here and I'm going to do something. What am I going to do here? I'm going to say whenever I remove a certain value, like 3, I'm going to set my count to 1. Okay, so that I'll be not execute, I'll be not remove, I'll be not removing the other remaining 3 values. And then how am I going to do so? Which means I have to use an if here. Just I think we need only 3 lines, guys, to fix this issue. So if I say if then I'll put an open bracket here and then another bracket here. I'm going to say if what? If my count is equal to 0. Okay, what am I doing here, guys? I'm saying, okay, guys, if count is equal to 0 here, because it is going to loop just inside here, so my count will be equal to 0 and then it will be looping this loop. Okay, but whenever it gets inside here, it only have to execute this code once, so that you can remove the value of 3 once in the linked list. Okay, so this is why I have put here this condition, so it will come here and it will test this condition, guys. So whenever the 3 here is equal to the element at index I, which means maybe at index 4, which means you are going to get this if statement true, then it will get inside and then it will test again. If count is equal to 0, yes, it is equal to 0 because we didn't change its value, then it will come here and it will remove the value of 3 and it will add the value of 3 at the front and it will set count equal to 1. Then whenever it encounters another 3, guys, yes, it will get inside this loop, but it will not be able to remove the other 3 elements. Why? Because our count will be equal to 1. Okay, our count will be equal to 1 because we will be setting the count is equal to 1 here. That's how am I going to terminate the looping of this the execution of this code. Okay, guys, so let's run this and let's see what are we going to get. Okay, our result. Yes, I'm so confident. Yes, you see here, guys, we've managed to take these 3 and place it at the front and the other 3 remains at their position, guys. So we have to say well done, guys, for this question, guys. So I have to say thank you, guys, for watching this video. If you like it, guys, just let me know in the comment section, guys. If you feel that I have to improve on a certain thing that I have to improve on the future videos, guys, let me know in the comment section, guys. If you like it, press the like button. Also don't forget to subscribe, guys, to this channel, so that and also turn on the notification bell, so that whenever I upload a new video you get a notification, guys. So guys, I have to say thank you. Please subscribe to this channel.